Hello, today we'll look at some examples of direct and inverse variation. All right, so just a really quick review. For something to directly variate with something or to have direct variation, y varies directly with x. So that means as y increases, x increases, or vice versa. So y is directly proportional to x. So that basically means that y is equal to kx for a constant of k, and it's linear, it's a line. And so here are some examples. Y equals kx, or k is equal to y over x. So it's directly proportional. All right, so inverse variation states that y varies inversely with x. So that means as y increases, x decreases, and or vice versa. All right, so y is inversely proportional to x. And so it is exponential in form, and we have y equals k over x. We have here are the example formulas: y equals k over x or k equals xy. So it's not proportional, it is inversely proportional. And sometimes you'll see inverse variation or indirect variation. They are the exact same thing. All right, so now we'll determine whether each equation represents direct or inverse variation. All right, so the first one, and I'm sorry, I forgot to pull up my pencil. All right, so the first one, if you can recall, direct, I'm going to put a D for direct, and an I for indirect or inverse. This varies proportionally, so K is equal to, which is the proportional amount, Y over X, and for inverse, K is equal to XY. Also, Y is equal to KX, and Y is equal to K over X for inverse. All right, so let's see which of these, the formula that this looks the most like. So here, if I want to, I usually try to use the top view formulas to help me to decide. We can look at other formulas as well, the bottom formulas, but I usually use that. So I usually try to solve for my proportion K. So that means I want to get my term by itself. So that means I need to multiply both sides by X. And I get XY is equal to 6. Well, the form of XY is inverse. So that means this is inverse or indirect variation. So we'll put an I beside this. All right, the next one again, I'm just going to multiply both sides by X. And I get XY again is equal to 10. And again, it's in this form, so we'll put an I here for inverse. All right, the next one, I'm going to divide both sides by X squared. And I get 6 equals Y over X squared. And so the form that has Y over X would be direct variation. Here I'm going to divide by X to get my X and Y together. And so I get 25 equals Y over X. Again, that's direct. It's in this form. Over here, I'm going to divide by X cubed. And again, my Y is over X. So again, that is direct form. Here we're going to divide by X. So my X's go away, so that's Y over X. So that is in direct form. Here I'm going to multiply by X squared. So that's XY form, so that's inverse form. So it crosses out. And again, multiplying by X cubed. So that's X cubed times Y. So that is in inverse form. All right, let's do some examples where we actually find the inverse. So all of these are directly. So this is directly, directly, directly. There are two ways that I could do direct variation. And the only reason I can do this in two different ways is because it is directly proportional. So that means I can actually use what I know about proportions. So if you recall, we know that k is equal to y over x. So if these are directly proportional, I can set up a proportion. So let's do that. So we have, it says if x varies directly as y and x equals 27 when y equals 6. So we'll put that in there. Let's put 6 over 27. I want to find x. So I'll put an x there when y is 2. And I know that just because they're direct proportional. And we'll do it another way for the next problem. So I'll cross multiply because I can cross multiply. That's going to give me 2 times 27, which is 54. So I can get 54 equals 6x. Then I divide by 6 on both sides. And that gives me, come over here and write it, x equals 9. So I want to find x when y equals 2, so x equals 9. We didn't even find our k for this one. For the next one, let's actually find our k. So we have if z varies directly as x and z is equal to 30 when x equals 8. So we'll say k is equal to 30 over 8. We can leave it like that in that fraction form. Actually, we have to reduce it. That's 15 over 4. Or if you just cannot stand fractions whatsoever, you can turn it into a decimal, which is 3.75. So now I can plug this into, so this time I found k. The last one I didn't find k. Technically I did because I can use this value for k. But we'll take what we have here. So k equals 3.75 and we'll plug it in to find z when x is 4. And so we'll say for the formula, we remember it's y equals k x. We have z though. So we'll say instead z is equal to kx. So we want to find z. So z is equal to 3.75, which is our k, times x, which is 4. And I get z is equal to 15. All right, so I can go back and check that with my proportion if I would like. So that's 30 over 8. And I can quickly see that, right? Is equal to 15 over 4. Yeah, they equal to each other because all I did was multiply top and bottom by 2 to get the top and bottom here. All right, let's do one more. Again, we have two different ways that we can do it. I prefer the proportion. So let's set up a proportion. We have 150 because d equals 150 when t equals 3. And I want to find d when t equals 5. Again, this can be used as my k value over here, which is 150 divided by 3, which is 50. We can use that k as our 50. So let's write that over here just in case we want to go back and show the other way. I cross multiply, so 150 times 5 is 750 equals 3d. So divide both sides by 3 and I get d is equal to 250. Why not just go ahead and try the other way too, just to see if it comes out the correct way. So we say d is equal to 50 times 5, and we know that that is 250. All right, so the two different ways to do it. When we're doing inverse variation though, it's not directly proportional, so we can't use those proportions, right? So we have to use the formula instead. And so the formulas that we're going to use for inverse will be k equals xy and y equals k over x. All right, so it says y varies inversely as x, and y is 23 when x is 8, and find y when x equals 4. So I'm going to plug this right on in. I'm going to find k, so k is equal to 23 times 8, which is x times y. And I get 184. And so I can use this formula again to find out what y is. So k, oops, not k, because I know what k is, so I can plug that in. So 184, which is my k, is equal to 4y, because the 4 goes in for x. Divide both sides by 4, and I get y is equal to 46. Could have used this formula also, but I'm sticking with this one. All right, it says if y varies inversely as x when y is 14 and y is 14 when x is 8, find y when x is equal to 7. All right, so again we'll say k is equal to xy, which is 14 times 8. And I get 112. So then I'll plug in that 112 is equal to my k. I know x, so that's 7y. I want to find y. Divide both sides by 7 to find y, and I get y is equal to 16. And I hope that this helps.